Hi everyone. Let's walk through and see how to do this assignment on the thermal envelope. What this assignment asks you to do is to take a look at uh, existing construction, right? And it could be a wall of your home. It could be a wall from your case study. It could be from some other resource, right? You're going to sketch a section through that wall. You're going to um, add up the R value, total R value for that wall, right? And invert that to also find the U value. And then finally, you're going to check that to verify it against current code and see whether that wall meets the code levels, right? It's okay if it does or it doesn't, but we're going to check. So for this example, I'm going to walk through one of the walls from your ARC 110 print reading course. And hopefully you all remember the brick veneer residence. All right. On the left, we have kind of a three-dimensional section through this wall. So we're looking at kind of the typical wall area right here, not through the window, but what kind of your more typical wall would look like. And over here on the right, we have the drawing of this section. So let's we're interested in this area down here. Let's zoom in on that. All right. And you can see what this wall looks like. Now, for your sketch, I asked you to just quickly draw this up by hand, or you could have done a AutoCAD sketch of this. And here's what mine looked like over here. I drew it up at the 1 inch equals 1 foot scale and quickly realized that was really small. Right? So I apologize for that. And then I did it, I continued at a larger scale. So looking over here, this is what we're expecting. This is a wall section, all right? And starting from the interior, because this is the interior face over here, we have, and this would not be typically labeled on a construction drawing, but we've got an inside air film, right? We've got the 1/2 inch drywall. And then this section from here to here is the wood studs, all right? But if we're cutting in between the studs, what we see is an airspace and then our batt insulation, right? And I know it looks different than this drawing here, but when you go take a look at the specs for this project, they're actually calling for 2-inch foil-faced batt insulation, right? Which would give a gap or a space right here. Next, our exterior sheathing here is 1/2 inch fiberboard. There is an air space right here, and it on the construction drawings that's not labeled or dimensioned in any way, but I'm going to assume that it's less than 3/4 of an inch. Right. Finally, we have our brick veneer, thus the brick veneer residence. All right, that's 4 inches thick. And on the outside, we're also going to have an air film. Now, some of the materials listed here, I'm a little confused. I'm not quite sure what they are, so I had to go check the specs for this project. And it turned out this, what they're calling 1/2 inch fiberboard in the drawings, when you take a look at the specs, it is, where is it? Wall sheathing, 1/2 inch rigid foam insulation panels. All right, well, that's different. So it's important to know that. And the other thing, what about these 2-inch foil-faced batts? And why is that different than this drawing here, which clearly shows the whole section filled? All right, we can go to the insulation section of our specs. Where is it? Where is it? Insulation. Between studs and outside walls, and still install 2-inch foil-faced fiberglass batts. All right, so that's information is important. Our next step in this assignment is to start quantifying the R value of these different layers in our assembly. So I've taken the information from our sketch right here and put it in a table. And I'm just literally listing all of our different materials and their thickness on the left-hand side right here. And then we're going to find the R value of each layer. In some cases, we need to know the R value per inch, all right, but not in all. Where do you get this information? Your number one resource should be Table J in your textbook. So let me turn this page over here. And here we have Appendix J, and moving to the table, let me zoom in here. We can see that we've got a list of materials, and some of them have a thickness listed. We have an R value per inch. Some of them have an R value for a particular thickness. All right. So I've gone through each of these pieces and found them in our table. For example, let's skip the air film for now. I'll get to that in a second. This 1/2 inch drywall, you can take a look. It's actually on the next page. All right, and gypsum or plasterboard, we're going to call that. They have it listed for a 1/2 inch right here, and the R value is 0.5. All right. So we found that for the drywall. The 2-inch fiberglass bats, all right, I found up here our fiberglass blankets per inch, all right, and so it's 3.5 per inch times the 2 inches, and we get an R value of 7. Okay, I'll get to that derating factor in just a second. We did the rigid foam insulation board. I found it here as I looked through the rigid boards and then turned to the next page. I found a fiber board. Remember that was listed specifically for our project. Per inch, it is 2.6. All right, so 2.6 times the 1/2 inch, we get 1.3. We got our 4-inch of brick. That was kind of the first thing. It's on the first page of this table. Brick, 4 inches. For the thickness listed is 0.5. All right, so that's how I got all of those different values. Okay. Next, we want the air film, a 1.5 inch airspace, a less than 3/4 inch airspace, and an outside air film. So we're going to turn the page from table J.1 to table J.2. And that's this page right here. And I've annotated mine just like I did in the previous lecture to kind of help us figure that out. Let me zoom in on this a little bit. Okay. So our inside air film, still air inside, move to the walls section, we're looking at 0.7. Okay. Our 1.5 inch air space is greater than 3/4 of an inch. And so that's here in the air spaces. Here is greater than 3/4 of an inch. It says 3/4, but it means greater than or equal to 3/4 of an inch. And that is 1. But I just realized I made a mistake because that is without the radiant barrier, and we've got a foil-faced bat right there. So I need to slide over here to our section with the radiant barrier and use a 3.4. You can see that makes a big difference. Where was that? Right here. 3.4. Okay. And that's because this is foil faced, our next section right there. Next, we have an airspace that's less than 3/4 of an inch. So we're here, airspaces, vertical, walls. It's not greater than 3/4, so it's going to be 0.9. Okay. And we finally have an outside air film, and that should be, let's see, air films outside, use the average of 0.2. There we go. Now, what about that derating factor? Well, here's the deal. Remember that this fiberglass bat is intermittent. All right, it's not continuous, it's interrupted every now and then by the 2x4 wood studs. So we can't calculate it as if it were a complete wall of fiberglass batt. We have to take that down a little bit. It's like a hack for accounting for those intermittent interruptions. And so you need to turn to this page in your textbook. Where is it? I found it right here. All right, with the table for thermal bridging's effect on insulation. Okay. And we're using 2x4 wood system, and so that derating factor is 80. All right, that's an 80%. Over here, we're going to take our 7 R value for those fiberglass batts and multiply it by the 80%, all right, and get a derated amount of 5.6. You are only applying that derating factor to the fiberglass batts because they're the only ones that get interrupted by that 2x4 wood framing system. By the way, this image that I'm showing you, table 15.8a, is outdated. That is the older edition of the textbook, just because that's the one that I have on PDF, so I'm able to show it on the screen. All right, so over here in the assignment instructions, this table that we're just looking at is 13.3a and b on page 477 of your 5th edition textbook. All right, so if you're looking for that. All right, so far we have investigated a wall assembly. We have found all the different layers and their R values. We added them up. We now have calculated a total R value for our wall assembly and also converted that into a U value. Why did we do all this work? Well, what we're interested in is whether our wall assembly meets code. All right, have we met the code for thermal envelopes? So let's take a look, and I'm interested in 2018 International Energy Code. All right, and this is a residential project, so I can use this link, and we're looking for the wood frame wall R value column of table R402.1.2. All right, so let's take a look. And with this link, we are shown Chapter 4, Residential Energy Efficiency. What was that number again? 402.1.2. We can go over here. We can find section 402, 402.1, 402.1.2, insulation and fenestration criteria. I'm going to click there. Okay. So the building thermal envelope shall meet the requirements of this table based on the climate zone specified in Chapter 3. Okay, that sounds like we need to investigate the climate zone first. Coming up here to Chapter 3. All right, it looks like we got Section 301 climate zones. I'm going to go ahead and click on that. We've got a table here. Sorry, a map here is what I meant to say. And I'm going to assume that we are right here in climate zone 5. All right. And if we were interested in this piece, we could take a look more specifically for Pennsylvania. LMNOP. All right. And we can see that most of Pennsylvania is in Section 5 and some in 6. But anyway, okay, so Climate Zone 5, that's what we're interested in. Coming back over here to Section 402, right, that we were interested in. Okay. All right, we got a Climate Zone 5. So now we need to read this table. Here we go. Insulation and fenestration requirements by component. We're going to look at Climate Zone 5. So it's this row. And then what are we looking for? Not fenestration, that means windows, not skylights, not ceilings. Aha, wood frame wall. That's what we're investigating. Wood frame wall R value for climate zone 5 needs to be 20 or 13 plus 5, and it's got the little footnote H. Always, always read the footnotes when you're looking at code. All right, so let's scroll down. H. It says the first value is cavity insulation. All right. Cavity is the space within the wall. The second value is continuous insulation. Therefore, as an example, 13 plus 5 means R13 cavity insulation plus R5 continuous insulation. Okay. Well, what do we have here? First of all, notice that nothing is said about the total R value of the wall. Right? We calculated that, but we're going to set it aside for now. That's not what we're interested in. They're interested in the R value of the cavity insulation and the continuous insulation. All right, let me do this here. Okay, so looking at our information here, we've got cavity insulation, all right, which was R7. All right, they're not using the derating factor. Our cavity insulation was R7, and our continuous insulation right here is R like 1.3. All right, where'd that table go? Here we go. So do we meet 13 plus 5? No, we are 7 plus 1.5. We do not meet those requirements. Okay. So what do you do if you don't meet the requirements? There is one more place to check, and that is if we scroll down, the U factor alternative. All right, you can check the code requirement a second way. And what it means is this is an alternative to the R value in the other table. So you can meet one or the other, it doesn't have to be both. So let's see. Here we are, equivalent U factors, and we've got our climate zone 5. And remember, we're looking for a frame wall. This is our U factor. The one that we calculated, that's why we did the calculation, by the way, the one that we calculated is 0.076. All right, and our frame factor is 0.060. Hey, we're higher than that. Is that good? No. All right, we have to, this is a maximum for the U factor. All right, we have to be under the code requirement for the U factor. So we are too high. Our wall does not meet code. All right, and this would not be an approved wall assembly under today's code. All right, everybody, I hope this walkthrough has helped you complete this assignment. Maybe you know where to start. Maybe you have figured out a couple of important points. I really want you to pay attention to adding up those R values, to getting the correct air films and air spaces, to make sure that you are using the derating factor on the correct component of your wall assembly, and also to make sure that you add up all your R values first and then calculate the U value. All right, you can't do it the other way. You can't calculate individual U values and add them up like you can the R value. All right. And finally, we walked through how to use these tables in the code. Thanks.